thanks goes to the Honorable Professor Amir and the University of Technology, Sydney, for graciously partnering with us to host this very prestigious event. Let's learn more about Professor Amir. Professor Amir's contributions have earned him numerous accolades, including the highly cited Research Award from Web of Science for 6 consecutive years. And this type of accolades do not place him just at the top 1% of researchers worldwide. They place him at top 0.1% of researchers worldwide. He was also ranked among the top 50 researchers in the AI and image processing subfield in 2021 by Stanford University's Elsevier ranking. All right, perfect. Now it is my distinct honor to invite Professor Amir to deliver the keynote address. Thank you. Professor Amir.
Hello, and good morning to everyone in Asia, Australia, and good evening to everyone in the US. I think also it's a night time in Europe. Thank you so much for Quantum Insight for having me, and particularly Dr. Vishwanda for inviting me for this event, and also all board members. It's a real pleasure and honor to have this plenary speech and in front of the esteemed colleague. Let me share my screen. It seems I have an issue. Okay. No, it's good. Could you see my screen?
Yes, we can. We can see you.
Yes, we can.
Okay, wonderful. Share it then. So now it's an era of AI, data-driven method, evolutionary intelligence, artificial intelligence. So I think this conference and also this talk, it's really in cutting edge and also on point and on time. I'm a professor of data science at the University of Technology, Sydney, and also I'm affiliated with AIIBD University at Budapest as a distinguished professor. So I quickly dive into the presentation, which basically talk about general AI impact and also a little bit focus on evolutionary intelligence. So what is AI? Basically, the ability of a machine to perform cognitive function we associated with human brains, such as perceiving, reasoning, and learning. And all these 3 factors usually repeated when people define AI. And going back to the timeline of AI, the basic algorithmic part for machine learning actually started from legendary work in early 1800. He actually did some groundwork for machine learning and some mathematical proving at the time. And of course, explosion of data happened in 90s when World Wide Web came to picture. We had lots of development in this way. For example, Andrew Ng developed GPUs for deep learning, which really boost and open a new line of research for applying deep learning to images and videos. And I do remember some games actually had lots of effect to make popularity for AI. When I was a kid, there was one chess match between Kasparov and computer. So Kasparov is a legend in chess. So at the time when computer could beat Kasparov was really big on the news. So people can see in such a cognitive function and those I can say complex rules and games, it can beat even the legend in humans. And some other games such as IBM Watson's beat Jeopardy, or if you remember a few years ago, Alpha Zero or Alpha Zero Go beat the champions of Go. So this was really also breakthrough. You saw it live because I think Go actually I can call it a mega chess. It has far more combinations that chess. So that was also big on the news. And we had ChatGPT a few years back. You saw it. It was really even changing the landscape of the different businesses. So talking about the businesses and performance of AI, possible performance of AI and current research in this field, I can refer you to this nice study by Harvard Business School, Technology and Operation Management. So they basically tested a skilled worker, or better call them knowledge workers, when they perform 18 different tasks. So they compare their quality, speed, a number of tasks completed, and you can see in the terms of speed, 25% increase in the speed and 40% increase in output quality, which actually is huge. You can see the plot in here. It's a big shift when people use AI for these 18 tasks. And it also happened for both bottom half skill participant and also top half skill participants. You can see in both cases we have significant improvement. For example, a score on task 43% improve on bottom half skilled workers and 70% on the top half skill participant. And that's all. If you follow the Epoch AI, this is basically a website for benchmarking AI and AI tools. So I borrowed this plot from these websites, and which actually shows how AI now can outperform PhD level scientists in science question. This is focused on physics problem, but these are some benchmark and could be even expanded to other areas. And you can see from the beginning of 2025, lots of AI tools such as Gemini and OpenAI model and others could outperform a human expert. So this is basically the human level. And you can see from 2025, some of these models could outperform these benchmarks, which was very interesting. You can find actually other benchmarks in these websites. And looking on different industries, this is a plot actually I borrowed from McKinsey. So the x-axis basically says current AI adoption in different sectors. And what's interesting here is y-axis, which shows the trajectory, AI trajectory or demand in the next 3 years in each of these different industries. And what's interesting here is the sectors or industries that right now using AI significantly, even going to invest more in AI in the future, which means they had a very positive feedback by using AI. And talking about my research in this area, I'm using AI tools in solving different challenging problems. So basically my field is applied AI. We do lots of predictions such as classification, regression, and clustering. We apply lots of these tools in optimization problem. Could be multi-objective, dynamic, problem, and also for automation, for, of course, decision-making process and smart systems and robotics. And my background is also engineering, so I'm also familiar with lots of problem domains such as smart cities and civil infrastructures. So quickly jump to how AI can be used for data analytics. I can say there are so many different tools, but I listed lots of them here. But one is could be different from others is this genetic programming, which is basically an evolutionary data-driven tools. So I know we have limited time, so I can skip all of those. Description about evolutionary data analytics, and this is our current research.
Scientist, Professor Amir Gandomi, is at the forefront of a machine learning evolution, developing new tools for big data solutions inspired by natural selection. Just as nature solves its problems through evolution, genetic programming produces new, improved generations of programs. Genetic programming develops programming models through evolution. Using a machine learning model is like buying an existing house, whereas genetic programming is like building one specifically tailored to your individual needs. Divide and Conquer provides big data solutions, breaking down problems and assigning the pieces to specific genes within a chromosome. Alpha Program views each individual program in a population as a chromosome, taking the best genes from each one to create an alpha program. It's a Frankenstein-like process, borrowing the best features from others to create another individual.
And evolutionary intelligence is only one tool out of the big toolbox of AI. We do lots of, for example, deep learning. We use, for example, particularly when we deal with images and videos, we do lots of NLP and LLMs when we deal with, for example, text, and so on and so forth. So you can choose the tool you need out of this toolbox if you're facing challenges, problem. And it has a huge impact on different industries. I showed a few of those studies, but there are many out there right now, actually, as a big evidence and a strong evidence for impact of AI in businesses. And basically, it can affect in so many different ways in the companies and improving their performance. Thank you so much again for attending this event and also having me in AI innovation in business domain. I'm sure you're going to have wonderful sessions. I already saw the speakers, lots of colleagues and esteemed researchers. I would be happy to answer your questions. If any quick one, I'm not sure if you have time for that or not, but feel free to reach me out if you don't have time here. Thank you.
Thank you.